Welcome to yet another exciting educational video brought to you by Operation Concepts Academy. So today we'll be looking at what are limits. AP Calculus Lesson 1. What happens when a function's value gets closer to a point but never reaches quite that point? That's the mystery of limits, the building blocks of calculus. So whether you are aiming at a 5 on the AP exam, or you're just trying to finally get derivative and integrals, this is the first step. So let's break it down. So in today's lesson, we'll be learning what a limit is and how it is expressed. Secondly, you will see how to estimate limits using using tables and graphs. And thirdly, why are limits essential for calculus? By the end, you'll be able to evaluate basic limits and understand their roles in defining derivatives. So sit tight and relax, enjoy the video. If you're yet to subscribe to our channel, can you subscribe to our channel, Operation Concepts Academy, and we'll proceed. So, a limit is actually the value of a function as the input approach a particular number. Mathematically, if I have limit of this function f of x, as x tends to a, this is how you read it, x tends to a is equals to L. So the key is that the limit is about the function approaching, not necessarily what is equal to. Okay, not what necessarily is equal to. For example, okay, if I have the function of x is equals to x squared minus 4 over x minus 2. So if we plug in x is equals to 2, the function is undefined. When we say we plug x is equals to 2, that's if x is equals to 2, for instance, and you put it in this value, in this expression by substitution, what we'll be having here is that x, whenever we see x, we put 2, you understand, square minus 4 all over x again here minus 2. So x squared is 4 minus 4, that is numerator, all over 2 minus 2. You see that this numerator, 4 minus 4, sums up to 0, and 2 minus 2 sums up to 0. So this actually is undefined. It's undefined. So as x approaches 2, this I'm going to put it here. As x approaches 2, this function go into a number, and that number is 0 for this particular case. Okay, so I'm going to actually look at visual examples. So the table shows a graphical representation of what I'm talking about. So if you look at this table for f of x, as x tends to 0, f of x is a function, remember, and this is x. So whenever we see x inside this function f of x, we'll put a value here. All this value, we try this value, try this value, try this value, try this value. So we see that the closer x tends to 3, as in this instruction here, as x tends to 3, f of x tends to 5. So you see that there's a gradual increase. When we put x as 2.9 in the function, I get 4.95. If we put x as 2.95, I get 4.9995, 4.995. If I put x as 3.01, I get 5.00. So as x tends towards 3, f of x tends towards 5. So why limits? Why limits? So why does limits matter? What do we do with limits? Actually, limits are foundation to calculus. They are foundation to calculus or derivative. If I have on the board, for instance, f of the derivative of f of x, once you see this sign here, it shows that the functions have been differentiated. We'll talk about differentiation later in this program. So if we have this function, the derivative of f of x, and as the limiting as h tends towards 0, this is the function. Okay, So we see that this is actually used in rate of change to calculate instantaneous rate of change, like speed of a car at exact moment. You will see what this thing stands for. If, for instance, now I am trying to compare a value, f of x value over h value, for instance, and you see that at this point, there's a rate of change. So this is the starting point, and by the time you add something to x, I have x plus h, that is from here to here, and this point too is h to this point. So I have it as h, and this the difference between here and here is f of x plus h plus f of x, sorry, minus f of x. So if I remove this from this, I have the difference, and this is the x-axis. So that the rate of change is f of x into x plus h, as f into x plus h minus f of x all over h. So this is derivative. This is change. The change, that's like the slope of the particular value. So I have on the board a simple question here. It said evaluate 2x plus 3 limiting as x tends towards 4. So this one is just a direct substitution that we're going to be doing here. So what is saying that anywhere I see x, let me just put this value 4. So the solution to this is 2 open brackets. When you see x, you put 4. I can put 4 here plus 3. So 2 times 4 is 8 plus 3. 8 plus 3 is 11. So the answer that's of this function as x tends towards 4 is 11. Okay, so go to the second one. So I have another one on the board. It says that we should get the value that will solve this, limiting when x tends to 1, what is this function limiting to? Okay, so in all problems involving limits, just know that there are two parts to this question. They will give you the part that has to do with the limits and the part that has to do with the function. So this is the function where x is embedded in it. Okay, so now by the time you say let us use substitution method to put into this one, you see that when you put x is equal to 1 here and x equals to 1 here, you will get 0. So everything will just become indeterminate. Understand? So, but what we will do quickly, if we are seeing that, we're going to use the method of factorization. So factor the numerator, factor the numerator. What do you get? You get numerator as x minus 1 and x plus 1. This is the difference of two squares for numerator. And denominator remains the same, x minus 1. So if x minus 1 is downstairs here, that's under the denominator, and x minus 1 is in the numerator, they are common. I can cancel each of them. And after, I'll be left with x plus 1, which is factored. Meanwhile, I can now apply the limit here. As x tends to 1, what is this function? So wherever I see x, I put 1. So it's 1 plus 1 is equal to 2. So this function, as x, limiting as x tends to 1, this function becomes 2. That's the answer. So if we try for those problems that have fractions, numerator and denominator, if you see that it's indeterminate, that if you do direct substitution, you are getting 0, you have to factorize, make it simple first, and see what you will get. So move on to the next one. Okay, so we have this on the board. It says that we should look for the limiting as x tends to infinity, what this function will become. Understand what this function will become. So the solution, first of all, we'll divide the numerator and denominator by the value of x squared. So we're trying to just solve this first, so make it simpler. So I would say divide numerator and denominator by x squared. So I would say 3x squared over x squared plus 2. Okay, plus 2 over x squared all over x squared over x squared plus 5 over x squared. See what I have done to the numerator and this is the denominator. So this one we cancel this one, and this one we cancel this one. What is left now is 3 on this side, on this term, at 3 plus I have 2 over x squared all over. Then this one is 1, that's the cancel is 1 plus this one is 5 over x squared. So I cannot conveniently put my infinity substitution here because I'm told that as limiting x tends towards infinity, what will this function become? So this function will become, this is now this, and if I put x as tending to infinity here, or put infinity where x is, let me come to this side so that I can use the board here. So 3 plus, so where I have 2 over x squared, I'll say 2 over infinity square all over 1 plus 5 over infinity square. You know this is already 0. It's already 0. This is 0. This one is 0. This one is 0. So I have 3 over 1. So answer is 3. So my answer for this question is 3. So we'll move on to the next one. So I have this final one on the board for this particular video series. So I have a table first of all, and we're going to estimate for this function as x tends towards 2. So this is the function, and these are the values of x progressively. So it's just by inspection. When x is 1.9, sorry, f of x is 3.5. When x is 1.99, f of x is 3.995. When x is 2.01, f of x is 4.005. And when x is 2.1, f of x is 4.05. So by inspection, by looking at this table, see that as x goes towards 2, what will f of x go towards? F of x will go towards 4. That's the answer. So by looking at the value, as x near 2, all right, they get closer to 4. So 4 is the answer for this particular question. This is very easy. Your AP calculus exams, very, very easy. So as a form of a recap, a limit tells you what a function approaches, not always its exact value at that point. So it's what approaches. So it can be like approximate. That's why you are seeing this one now. It's like approximately 4. So we can evaluate limit using substitution. We'll see where we are using limit using direct substitution, factoring, graphs, or table. And finally, limits are the gateway to everything in calculus. So we'll be seeing calculus in this series of videos, derivative, integrals, and much more. So I hope this lesson has been informative for you. I'd like to thank you for viewing. Please like, subscribe, and up next is one-sided limits and continuity.